Hello everyone. This is a problem from statistical mechanics. Here, consider one-dimensional chain consisting of n greater than one, much more than one segment as illustrated in the figure. So this is our figure where we can see one chain is vertical to the length of the chain and one is horizontal to the length of the chain. And let the chain of each segment be when the long dimension of the segment is parallel to the chain. So it is giving contributing length A, and it is 0 when it is vertical. So when the long dimension of the segment is parallel to the chain, it is giving us A or contributing A to the length, and 0 when the segment is vertical, that is long dimensional normal to the chain direction. So each segment has two states. One is horizontal, other is vertical. Fine. A horizontal orientation and a vertical orientation, and each of these state is non-degenerate. The distance between the chain and is nx, that means the length of the chain is nx. Then we have to find the entropy of the chain as a function of x. Second, obtain a relation between the temperature T and the chain of the chain and the tension F, which is necessary to maintain the distance nx, assuming the joint turn freely. The third one is, under which condition does your answer lead to Hooke's law? So this is our question. Fine. Firstly, we have to find the entropy. In order to find the entropy, we have to know the number of microscopic state. Fine. So as we know, here our length of the chain is how much? The length of the chain is n into x. Fine. Then number of segments parallel to the chain will be what? This is the total length. Fine. And when it is horizontal, it is contributing length A. Fine. Then if we divide by the length A, we are going to get the number of segments that are parallel to the chain. Fine. Then we are going to find the number of microscopic state is given by what? Omega. So total number is how much? And out of that, which are parallel, is now we have find out this nx by a. So this can be written as n factorial divided by nx by a factorial multiplied by n minus total number of chains minus the segments that are parallel. Fine. Then finally your entropy is given by what? S equal to k log number of microstate. So k log n factorial nx by a factorial n minus nx by a factorial. So this is our entropy. Fine. Second, they ask question, a relation between the temperature T and the tension F. Fine. So here what you can do, and in order to maintain the distance nx, so in that we can find the mean length. Fine. So under the force, what may be tension F, the energy difference, that is delta E, when segment is parallel, then it will be around F into A. Why so? Because work done or energy is given by force multiplied by displacement or distance, is it? And when it is the delta E, when it is perpendicular, it is contributing F into 0, that is giving you 0. So now firstly let us find the partition function. So partition function is given by the e raised to delta E when it is perpendicular. So when it is perpendicular, its energy is 0 by kT plus e raised to, when it is parallel, the energy difference delta E is given by what? Fa by kT, as partition function is given by what? Z e raised to delta E by kT and summation. Fine. So here are two states. We have two states. One state have energy F into A, and one state energy we have 0. So now we can easily find average or mean length. So in order to find the average mean length, normally what we know, average mean length in quantum mechanics or whatever, we know that length multiplied summation I, length multiplied by probability. Fine. So here also we are going to do the same thing. When it is perpendicular, so energy the length is 0 and multiplied by the probability e raised to, what's the energy when it is perpendicular? It is 0 by kT. Fine. And when it is parallel, the length is a and the state energy is Fa by kT divided by what? Partition function. So partition function is given by 1 plus e raised to 0 is what? 1 e raised to Fa by kT. Finally we can write it as e into e raised to Fa by kT divided by 1 plus e raised to Fa by kT. Fine. So this is our mean length. For n number of segment, what you can write, the total length will be n into L. Fine. So now, we can see this is the relation between force and the temperature, which is according to question. Now the second is what we have to find the Hooke's law from the answer, is it? So in order to find, we have the term e raised to Fa by kT. So at high temperature, when T tends to infinity, this term e raised to Fa by kT can be written as what? 1 plus Fa by kT, and the other square term we can neglect it, since this is very small quantity, and the denominator quantity with respect to 1, it can be written as 1. Fine. Since the term is very small, this term will be very small compared to 1, so we can neglect it and we can only use term 1, right? So therefore we will use the total length L into L. What is L? E, and e raised to Fa by kT can be written as 1 plus Fa by kT divided 1 plus, this is 1, so this will be 2. So L equal to n into A, 1 by 2 plus Fa by twice kT. So this is what? L is proportional to F. So this means what? Hooke's law, what it says, your force is proportional to the displacement or length. So it says that it is Hooke's law. Fine. Thank you very much.